Hello everybody, and I decided for a change of scenery this time. We're sitting underneath some slash pine and a little bit of Spanish moss too. And yeah, my wife said hopefully none of it blows in our face. That'd be bad. But I hope that you're enjoying your quarantine orders. I know I am. I'm enjoying the time I get to spend outside. My baby's crawling around, so she's having fun. We're talking about diseases. Sorry to change the subject, but the first one is pneumonia. Pneumonia is a general term for infection within the lungs, where there's a mucus-like fluid buildup. Lots of things can cause pneumonia, not just bacteria, viruses. There's even various sorts of microorganisms that can cause it that aren't bacteria and viruses. There are specific bacterium that cause just pneumonia. I think of Streptobacillus pneumoniae. Definitely lends itself towards pneumonia. You have this term aspiration. It means to take in by means of suction. If a person is aspirating, they're choking. So you don't want that. Heimlich maneuver, of course, is used to dislodge an object. Pushing up right around the diaphragm area will cause the object to become dislodged. With babies, you want to lean them over and smack the middle of their back, and that will force whatever is causing them to aspirate to return up their esophagus, or if it's stuck in the trachea or larynx or wherever it is. Lung capacities. Tidal volume is the normal volume of air during normal quiet breathing. So when you're watching Netflix, you are inhaling and exhaling, and you're only moving between 2 and 3 liters of air. Functional residual capacity is the volume of air left in the lungs after expiration. So, after you exhale, now we're not talking about exhausting everything out of your lungs, but after a normal exhale, oh, my baby's angry. After your normal exhale, there's approximately 1.5 to 2.5 liters left in the lungs. Total lung capacity, if you take the biggest breath you can, you got about 5 to 6 liters there. And residual volume is the air after you exhaust every last thing out of your lungs. So it'd be like going, and then there's nothing left. There still is a little bit left. You can't completely exhaust every last molecule of air out of your lungs. But that's why we call it residual volume, what's left. Residual. Now, I'm going to briefly get into respiration here, the chemical nature of respiration. Your book goes into a lot more detail. We're going to talk about that in a second. But anyway, exercise. Not a disease. We've left diseases. But it changes things. It increases carbon dioxide levels because you're working harder. Chemically, the carbon dioxide with water becomes H2CO3 hydrogen carbonate. And, ooh, she is angry. You hear her? She's like going over there. Anyway, H2CO3 becomes a hydrogen ion, and as well as a anion, HCO3 negative. And I'm going to take a short break. We're going to get some pizza. Back, we had a short pizza break. Nobody out pizzas the hut, so my wife's eating some pizza. It's good. Anyway, we have this H2CO3 becomes hydrogen ion and HCO3 negative. HC HCO3 negative is known as bicarbonate. Anyways, the more H plus or the positive hydrogen ion in the blood, the lower the pH gets. If you remember from chemistry, hydroxide, OH negative, makes things more basic. Hydrogen, H plus, makes things more acidic. Lower pH gets. Ventilation, or the rate of air exchange between the bodies, controlled by pH in the blood. So it's actually, you're not like breathing heavier when you run necessarily because your body is, because your body knows you're running, as much as your body's pH is lowered. When your body's pH is lowered, your body kind of goes into panic mode and tries to exchange more oxygen to get rid of the carbon dioxide, which is making your blood more acidic. So it's a little bit complex chemically.
Basically, running is poisoning yourself.
Yeah, running is poisoning yourself, my wife says. See, that's what I believe. So that's why I don't do it. Cellular respiration is the easiest way for your body to produce enough energy. This is through aerobic respiration. You take glucose, C6H12O6, you take oxygen, you respirate and it becomes carbon dioxide and water, producing 36 molecules of ATP. Some people actually debate that. Some say it's 32, some say it's 34. Through my personal studies, I find 34 is a little bit more accurate, but there's a little bit of a debate going on there in science. But your book says 36, so we'll go with 36. Anaerobic respiration goes on when your body cannot receive oxygen. And that makes glucose and makes it into C3H6O3. It produces 2 ATP by the breaking down of this large molecule into two smaller molecules. The problem is C3H6O3 is not something you want to get into your body. There's a bug on the screen. C3H6O3 is lactic. Oops.
No. No.
Yeah, lactic acid. Sorry, it was giving me the chemical name.
No.
I was questioning my chemistry skills there for a second. I was like, wait, what? Yeah, lactic acid. Anyway, you don't want lactic acid. That's what builds up in your, body when you exercise and your muscles are strained, can't get oxygen, you get lactic acid. That's what causes that, that muscle soreness the next day, after exercising. Now, these processes of cellular respiration and anaerobic respiration are not as simple as I just made them. Your book spends about 8 pages talking about their complexity. Every single thing that goes in and out of the process in order to make it all work. I encourage you, if you have the time or energy, and you probably have the time or energy, but take a look at those pages. You don't have to memorize, oh my goodness, you do not have to memorize all these processes. If I was to try and even pronounce half the stuff on these pages, it would be a total failure. There's an incredible complexity in your body, and it just makes me kind of thankful for a God who oversees all these things, because it's beyond my understanding how cellular respiration works, and it's one of the easiest things we do. We just breathe. And yet some scientists study for years and still debate on how exactly the mechanism works, and it takes about 8 pages to explain the basics of it. That couldn't have evolved by chance. We're not talking about a random evolutionary mechanism here. This is something of incredible complexity, and yet one of the simplest things needed to start life. And I hope that just the idea of that comforts you, that God is in control of all things, and by him all things consist, as the scripture says. Anyways, that's the end of the lecture, end of the respiratory system. If you hear all those cops and ambulances, I think it's time to shut down, so I'll see you guys. You have some anatomy coloring book work to do. Make sure you get that done and get ready for the test. Alright? Bye-bye.